Hello everyone, and welcome at this first in a series of videos for the course Introduction to Bioinformatics at Utrecht University. My name is Laura Dijkhuizen. I'm one of the teachers in the course. I specialize in metagenomics, so you'll see me for topic number 2, metagenomics, and I will also do the explanation for one of the primers that you can do as self-study before the start of the course. So the primer I'm looking at now is the how to work in a Jupyter notebook with the Bash language. So Jupyter notebooks will be used throughout the entire course, so doing this well and getting familiar with this is definitely worth your time. And at least for my part, the metagenomics part, but also for the genomics part and many other, you will use the Bash language among others. So what I'll do is I'll advise you first to make this primer by yourself. There's a lot of instruction in there that should get you quite a long way. And then if you're stuck, you come back to this video and I will explain all steps to you. Assuming you've now done the exercise, let's have a look. So the page we're looking at now, I'm assuming you already managed to log into the GoCalc server into your Introduction to Bioinformatics project, and you found in the files the topic 0, dipping your toes in the, command line, and then there's this one file, Jupyter and Bash Basics. There we go. So this is the web page. Jupyter notebooks are interactive web pages, so you can double click on a piece of text and you can edit this. Edit. I hit Control Return and it's again rendered as text. That's a bit easier to read. So the teachers in this course, of which I'm one, we have made pages like this where we have blocks of text. But the nice thing about Jupyter notebooks, I'll scroll a bit down, is that there can also be code introduced in these same pages. And I'll just show you what is it? A spoiler. This code can then be executed within that web page. The nice thing now is that all the bioinformatics software that we'll use in this course was already installed on the server on which these Jupyter notebooks are hosted. In other words, we're not spending a day or two installing all the stuff on your own laptop. That would be a waste of time. There we go. So you can select cells with your mouse. Point number 1. The same can be done with the arrows. Personally, if you type a lot, I like to use the arrows more. If you make a new cell, first thing, you can edit the cell by hitting return, and you can turn it back by hitting Control Return. You can also double click it and it will become editable. And I think there's a run button up here. Yes, the run button, and it will be rendered again. A new cell is by default a code cell, but you can turn it into a markdown cell. Let's first make a new cell. This can be done with the plus button all the way to the left here. There you have new cell, and you'll see indeed it is code. You can see this by the little brackets over here. I can now type something in here, ls, which is a command in Bash. I can hit the B key for below. It will introduce a new cell, and I can type something else. Who am I? I'm a code, very philosophical. Next thing I can do, I can hit the A key and make again a new cell, but now above. And if I want to remove all of these cells, I hit twice D. Remove, remove, remove. So that's how you can make new cells and navigate a bit in such a notebook. I hope you got this part so far. A code cell can be executed by hitting Control Return. A markdown cell can be rendered by hitting Control Return. We've seen this. The plus button we have seen. So the nice thing about the GoCalc interface, it doesn't work when you install Jupyter notebooks on your own laptop. But here it does work. You can also add a cell by clicking in between two cells. So here, it's kind of fancy. additional cells by the keyboard. I've shown you this. So I guess this is also an important one. We're doing this course with a bunch of people at the same time on the same server, which is nice because you can all share your challenges and collaborate. But it's also a tough time for the server. So what can happen at sometimes is that in notebook turns out to be unresponsive. Or perhaps you issued a command that's taking too long, you realize you made a mistake and you want to stop the command. There's a few simple things you can do. So first here there's the stop button. It says interrupt kernel, where kernel is basically the guy in the background doing all the work for you on the CPU of the computer. If that doesn't work, and at times it won't, we can go to the kernel menu up here, and then we can choose to interrupt the kernel when something is running. I can't now because nothing is running. If that's not efficient, we can restart the kernel. And restarting the kernel in that way is, I guess, a bit more aggressive. Any variables that you have stored in your notebook will be lost. You have to recreate these variables. Not true for files though. But usually this is efficient. If that's also not efficient, you can go to File and you can say close and halt. So let's do that now. And then the notebook is closed. And the background processes involved are stopped. I'll open it again, loads for a bit, and there we are. So, I hope you don't need it, but in case you do, now you know. Okay, so then the exercise that you should have done, you say at least one times a cell below, and you make it code, so it could be who am I? And one time you make a cell, you make this text. So making a code cell, a text cell, which is called markdown in this case. Markdown is just fancy text, let's call it fancy text. I hit M for markdown. Then now it's a markdown cell. I hit return and I can type whatever I want in here. Easy as that. Next step, so Jupyter kernels. Like I said before, the kernel is kind of the program in the background that does all the heavy lifting, where the Jupyter notebook is just the graphical user interface that you get to see. The nice thing about these Jupyter notebooks is that you can choose different kernels. These different kernels speak different languages, so you need to be aware of this. In this case, you can see on the top right here, I'm working in a Bash notebook. So Bash is the Linux mother tongue, as I'd like to say. If you're on a Linux computer or on a Mac computer for that matter, and you open the terminal, let's do that just for fun. I'm on a Linux computer, this is a terminal. The same commands that I typed before also work in here. Remove it again to use Bash. So if you're going to learn bioinformatics, these programs often work only on Linux-like systems. It's good to learn Bash. Another kernel that you have is, for example, Python. I think most of you know Python. R, you've done an R primer as well, or you're gonna do an R primer after this. And then there's SageMath, which I honestly have never used, so I won't talk about that. Moving on to Bash, already talking 9 minutes, time flies. So Bash basics, execute the cell below by hitting Ctrl return. So we've done this already. So what's happening here? The very basics of the Bash language. First we type a command, a certain program that's installed on the system, and then we give it an argument. So this could be, in this case, very simple, a piece of text, and the echo command takes this piece of text and echoes it back to you. Very simple, but you get the point. So of course I then challenge you to make it something different. Universe, hello universe, there you go. You can change this whatever, however you want. Another command that's quite trivial but very important is the list command. So it's shortened to ls, and it will give you a list of stuff that's in the folder that you're currently occupying. It's that simple. So we can ask for more information. So I gave you here a few examples. There's size and there's human readable. So let's do that. Minus minus size. Let's do first just this one. Size. And it will now give me the size of this file in kilobytes. That's default. So notice that I type now minus minus size. So here minus minus, oops, this part indicates that I'm giving the command an option. You don't have to do this, they're optional, but you can. Since bioinformaticians are generally lazy, we can do this also in a shorter way with a single minus and an S. Exactly the same thing. So let's type it in full again. The second option I want you to try is the human readable, which makes the numbers more human readable, if I can type at least. Human readable. There we go. Now it says 20K. It makes it a bit easier, and especially when you have a lot of bigger files, it's nice that this K will turn into an M for megabytes and a G for gigabytes. Okay, and since we're now lazy, we can remove these very long options by shorter ones. So minus S and a minus H give us the exact same results. We can even be more lazy. These short options can be combined into one. So minus SH is also the same thing. So we have learned a lot about bash and about options. In the next exercise, I want you to have a look in this data folder, but I realized I haven't put it on the server yet, so I'll pause this video and get it into place. Okay, there we are again. I put the extra data in place. So let's see, we now have not only this one file, but also the data folder. So let's do the same exercise for the stuff in the data folder. Surprise, in the data folder there's two more folders, so let's have a look in the data/reads folder. And there's a bunch of files, and now you can see that when I have the human readable option in here, it tells me that the files are 87 megabytes a piece, and if I were to remove that, so let's do that just for fun, it will give me their size in kilobytes, but that's not always very easy on the eye. So this is better. Autocomplete. So you may have already seen me use it. One of the best features of bash, I guess, bioinformaticians are lazy, is the autocomplete. So if I type ls and then space DA, I of course want to type data, the folder that we've been looking into. If I hit tab, it will tell me some options to autocomplete. Now since this fancy CoCalc system gives me these many options, that's actually not correct. There's just this one option, data. So use autocomplete. There's a second big benefit of using autocomplete. It's very hard to make typing mistakes. So this scaffolds.vasta.gz is perhaps a word that I would make a typing mistake in. But if you use autocomplete, it's very hard to make these mistakes. So let's say I do make a mistake in the word assembly like I did now. I forgot the M and I'm now trying to autocomplete scaffolds.vasta.gz. I hit tab. It will not work. So now I of course can be stubborn. Stupid computer, you can't find the file. I hit return, but it will tell me there is no such file nor a directory, because I made the typing mistake. So use tab, be smart, don't make mistakes. Next up, pipes. So often in bioinformatics we're taking data in one shape, then putting it through a program to the next, again to the next, to the next, to the next, etc. That's what often works. In the meantime, we store, so we get the data in a certain file format, and then we put it in a program, it becomes another file format. And every time you read this file from a disk and you write it back to a disk. But at times it's very convenient to not write it back and forth to a hard disk, which can be a slow process. that move it straight to the next program without ever having the intermediate steps reaching the hard drive. So, complicated, there's a reason for it. We won't go into details, let's just look how it works. So I'm again making a list of the stuff that's in the data/reads folder, and now typed ls and then a -1 as an option, which means as much as take one line for each entry that you're listing. So it's a long list now here, where just above it was more of a wide list. So what I can do is I can pass this data using a pipe to another program. In this case I put in here the program head, which takes the head of a file, so the head is the first few lines, and I give it an option -n the number 1. So you can guess what will happen. This will give me one line of the output of the command before. I can change this number to 5 and I will get the first 5 lines. I can put another pipe behind, tail and 3, and I will get the last 3 lines of the first 5 lines of that list, etc. And there's all kinds of things that you can do with pipes. They're very fast and they're very efficient. So let's leave that be. Pipes can make your life slightly confusing, but in the end a lot easier. Loops. So loops again are amazing, but before we can understand loops, we must understand what a variable is. So you know variable from your high school mathematics, I'm sure, but in programming, variables can be more often words than they are numbers, I guess. I hope everyone agrees with me, and if not, then you can find it. So what I did here, I made a variable and I called it very creatively variable1, and in there is the word coffee. Now the next thing I do is I use the command echo that we used before, but now I put in the variable. I have this $sign in the beginning here to indicate that it is a variable, and what echo will do is will give me the content of the variable. Let's say I remove the $sign, it will just echo back the exact words variable1. I put the $sign back in, it will give me the content. So that's great. The next thing that we can do is that in here, it is in here. Yeah, oh, and by the way, so some bash Nazi now is saying you have to do it with double quotes. Officially you have to do this with double quotes, but usually it works without. Moving on. So a variable is has a certain name, and you can put something in there. It could be a number or a word, but it's always one. Next thing, next level, so to say, is putting multiple things in one variable. You call this an array, so it's a list of variables, you could say. So what I did in this line here is to make this array. I called this array break. You can name them whatever you like, and I put in coffee, tea, the Dutch spelling, oh come on, tea and cookies. I define this variable, I get no output, I don't need any, I just define the variable. And now I can, let's put in a step in between. I should put in a step in here. I could ask echo break, and it will give me only coffee. Now that's confusing in a way, because perhaps you'd expect it to get in return coffee, tea and cookies. That's not entirely how the bash language works. So if I use echo like this and I declare it as a single variable, oops, it will only give me the first entry of that array. So for an array there's a bit of a different syntax, a way of typing. I type, let's do it from the start, a $sign, a squiggly bracket, break, square brackets, and inside those square brackets I type an at like this. And there we go. Now I get all entries of this area, and I can replace the at with a number. We start counting at 0. Will give me the first entry. I can take 1, which will give me the second entry. You see how this can be confusing, and 2 for the third entry. Simply start counting at 1. So keep it in the back of your head that this is how arrays work. So for 3 things, an array perhaps is in the end more typing than doing just everything yourself one by one, typing the words coffee, tea and cookies. But you can imagine that at some point, when you have hundreds of samples or even thousands of data points that you want to edit in some way, it could be really convenient to write a loop. You would say, I want to do this specific thing for each of these 1,000 data points, and let the computer do all the work. So let's see how we write a loop in Bash. Perhaps you know them already from R or from Python. Now we're going to write a for loop in Bash. So a for loop has a certain amount of, as a few essential steps. So we declare that we are starting a for loop by typing for. You do a certain part during the loop, and you declare that you're done. So let's look at this first line first. So in this for loop, I say for I in the array we just defined. So I now is becoming a variable, and the content of this variable will iterate over the different entries in the break array. So in the first iteration of the for loop, this will be coffee, in the second it will be tea, and in the third it will be cookies. Let's run this loop and see what happens. And indeed, I get back in, because I use echo, and then the $I, the variable, I see coffee, tea and cookies popping up in that order. So let's say I want, so what do we want more for coffee break? I want chocolate. I'm dyslexic, sorry. This is the Dutch spelling. There's break, coffee, tea, cookies and chocolade, since we're in the Netherlands, and we run the loop again. And there will be these extra entries. That's how you make a loop, easy as that. So the nice thing is that with this variable you can play a bit, so you could give it, for example, a extension .text will just work. You could use it twice. Something like this. That's a loop. So this is knowledge you'll definitely need in the metagenomics part, so make sure you have the first day to do these primers, play around with this a bit, make sure you understand how it works. Then we're going to the Bash extras. So this is stuff that you won't specifically need, but that will help you a lot. So if you have the time, definitely have a look at this. Wildcards. So wildcards can be used in command lines to take, for example, every item inside a certain directory. So let's see. So remember that we had this data directory before, and inside the data directory there were 2 new directories. One is called assembly and one is called reads. Let's see, I want to know what is in both directories. I could do something like this, ls data/assembly, and then below type ls data/reads. So what we get is first the content of the first directory and then the content of the second directory. So this works, we now have our answer. But let's again say that you have tens or hundreds of directories. This is not an efficient way. So remove the inefficient way and enter the efficient way. We put in a wildcard, so data/ and then a star. I hit return, and it will give me the content of every directory, or file for that matter, in the data directory. That was using a wildcard. You can also use a wildcard in a file name, so let's make it data/reads/e, then a wildcard .fastq.gz. So So what the command line will do is it will try to find all files in the folder reads that start with an E and end in fastq.gz. Will look like this. Let's say I want to, it doesn't matter for me what the files start with, but I want all files that end in r2.fastq.gz. Looks like this. Again, makes sense, and indeed you see that the beginning for each file differs, but the ending is always r2.fastq.gz. Also, that's basically that example. So here, I was very brief. So the base file names. So I will come back to this when you need it in one of the next videos. So the base file name is the part. So let's say you have a bunch of files, and you will later have this in the assembly folder. So in the assembly folder you have a bunch of files, and they share the beginning of their file name, but not the end. So the part that all of these files share, that's the base file name. And then you can add on top whatever you want. No examples there, just so you know. So like in the computer you're used to, be it Linux, Windows, Mac or Chromebook, whatever, we've been working with directories. And these directories are somewhere on a hard drive in a file system. And sometimes you may get lost where you are or where you should be in a file system. So there's some stuff to do. You have the pwd command, which is short for print work directory. It will tell you where you are. So I'm in the, so from the very base of the hard disk, I'm in projects, then this very long code, and then this folder, topic 0, dipping your toes, command line. So what now can happen is I can move to a different directory, change directory to, let's say I want to enter the data folder, data. So now let's see where I am. So you'll see that I'm in the same part of the directory tree, so to say, but now I'm in the data folder. So what will happen is, let's say I want to list what's in the original folder, in the dipping your toes command line folder. How do I do that now? Because if I type ls, I'm now in the data folder. So there's two ways. I can type ls ... meaning one folder back, and it will give me just that. I could also say I want to go back. I'm lost here, I want to go back. I type change directory ... and I am back. If you want to change back to directories, you type ... // You get my drift. So something you may have also noted is that you could type, so now I actually forgot where I am. Yep. You could type ls data / reads, like we've done before. You may see me do ls data / reads. So this is a habit that I have that you don't need to do. So what happens here? Dot is your current folder. Dot is the folder above. But let's say I start at my current folder and I then move into the folder data. So that's kind of the philosophy, if you will, behind using that / at the beginning of your command line. You don't have to, but in a way I like it because it's very explicit about what you want to do. I want you to list, starting at this directory, then moving into the next. Yeah, okay, so it could be, so you don't need to change directory much, at least not in the practical that I made. But if you run into an error like file not found, it could be that you accidentally move directories. So you can check with pwd where you are and with cd to get back to where you should be. Changing the work directory, we have done this. So then there is this, read the fucking manual. I hope I can swear on YouTube, I hope so. It's kind of funny, but it really is true. So a lot of these bash commands, this is the head command we've used, we've used just now. And the head command has a whole bunch of options. And if you type the option ---- help, and this is kind of universal rule for all kinds of bash commands. You'll see in this practical it's not absolutely universal, but close to. If you type the option ---- help, you get a help page. So reading the help page is quite often the solution to one of your pragmatic problems. On top, you almost always have this usage line which tells you how to use the command. So have a look at that. Often there's a very snappy description of what the command does, and there is a very so the jargon is sometimes very short and technical, but in this manual page you can find a lot of information. Again, because bioinformaticians are lazy, you often can type -h, and then most programs will allow you to type either -h or --help. As you can see here, not all of them do. So let's find another one. Word count WC -h doesn't work, but --help does work. ls -h does nothing, -help does work. So I should have a better example. Let's do, I made everything very big now. Oi, where am I? There. Grep is one of the commands we also use. Grep -h. Oh, come on. Nothing with a single h? I'm sure we will encounter one. Proca h. Finally. But I don't think actually this matters. I will do the same. Okay, so far for a good example. Let me get back to this. So what was I telling? Read the manual page when you get confused. If you have a command that you want to use, like the grep command, we can type either -h or, as we've seen just now, --help. And there you have your help page with this very important usage line, a really snappy description of what the program actually does, and a whole bunch of options, and sometimes there's pages and pages of these. Okay, that's it, you're now all ready. I guess what perhaps is nice to show you, and that's something that will not work in these Jupyter notebooks, but that will work when you're in your internship working on a Linux computer, is the manual pages. So let's do again grep -help. Make this big. Get the other window out of the way because this is annoying. And away. -help, and you get again this really long list of stuff that you can use grep for. So there's always also the manual pages. So man for manual grep. And there we have kind of the same. Sometimes it's a bit extended, sometimes it's not. A manual page. You can scroll through it with your arrows. So if you're ever in a bioinformatics internship on a Linux computer, be sure to check that out. Oops, that's definitely not what I want. There we are. If you made it through the entire video and the entire assignment, well done. Perhaps this is all very normal for you. Perhaps it's actually really tricky and you find it very hard. I think from experience, we've done this course a few years now. If you find this very hard, perhaps just try and do it again. I think it's worth your investment to really master this part before you move on. I'll see you at topic number 2, metagenomics, and until then, have fun with all the primers and topic number 1, genomics. See you in a couple of days.